Question number 5. A battery of EMF 2 volt and internal resistance 5 ohm is being charged with a current of 0.1 ampere. Calculate the potential difference between terminals of the battery. Also find the thermal energy developed in battery in 10 seconds. So we know that E equal to V plus IR. Here I times small r, where small r is internal resistance, or V equal to E minus I small. Here E is given as 2 volt and the current is 0.1 ampere and internal resistance is 5 ohm. So this will become 2 minus 0.5, that is 1.5 volt. Now, in question, this internal resistance should have been 0.5 ohm. In that case, the value will change. So it will become V equals 2 minus 0.1 into 0.5, that is 2 minus 0.05. So this will become 1.95 volt. Now, second part is also find the thermal energy developed in the battery in 10 seconds. So heat developed here, we will take this internal resistance as 0.5 for further calculation. So H equal to Joule's law, I square R T. Current is given as 0.1 ampere, so square of it times resistance. Resistance is given as 0.5 into time is 10. So if we simplify, so this will become 5 into 0.01. So that will give 0.05 joule. Now, let's go to the next question. Find the resistance between points A and B of the network shown. These two resistances are in parallel and this is in series. So first we will evaluate this. So this will be equivalent to RP, and then this is 2.5, which will be equal to sum of the two. So here RP will be equal to 10 into 30 divided by 10 plus 30, that is 300 divided by 40. So this will become 7.5 ohm and 7.5 in series with 2.5 ohm. So this will be equal to 10 ohm. Now, next question, find the value of R so that there is no current in 50 ohm resistor. So if it will be a balanced Wheatstone bridge, in that case, no current will flow through this resistor. So we can say that 10 by R must be equal to 20 by 40, which will give R equal to 20 ohm. Now, let's go to next question. The ammeter shown in the figure consists of 480 ohm coil connected in parallel to 20 ohm shunt. So actual picture is like this. This is 480 ohm and along with it there is 20 ohm here, and then this resistance 140.8 and then battery. So first we have to evaluate this, then we will add that value in this, and then V equal to IR will be applied. So let's evaluate. So equivalent resistance for this, so suppose this is RP. So RP will be 480 times 20 divided by 480 plus 20. So this will be equal to 19.2 ohm. Now, 19.2 ohm is in series with 140.8 ohm. So our total will be equal to 140.8 plus 19.2. That will be equal to 160 ohm. Now, V equal to IR we apply. So I will be equal to 20 divided by 160. So this will be equal to 0.125 ampere. Now, next question, question number 9. Here, a capacitor of capacitance 100 microfarad is charged by connecting it to a battery of 12 volt and internal resistance 2 ohm. Part A, find the constant of the circuit. Part B, find the time taken before 99% of the maximum charge is stored on the capacitor. So, time constant T equal to C times R. We put the values. C is given as 100 into 10 power minus 6 into resistance is 2. So that would be 200 microsecond. Then charge Q is given by CV times 1 minus e to the power minus t divided by tau. So C is this much, 100 into 10 to the power minus 6 into voltage is 12 volt, 1 minus e to the power minus t. T is given as here, find the time constant. So let's write it as our question is find the time taken. So T is to be found and the time constant is given as 200 microsecond. So this is Q and the value of Q is 99% of this value. So we can say 99 by 100 of sin 100 into 10 to the power minus 6 into 12 equal to 100 into 10 to the power minus 6 into 12 into 1 minus e to the power. Let's write it as minus t upon tau for time being. Later on, we will put the values. Where these two terms will cancel out and we will get 0.99. So 0.99 equals 1 minus e to the power minus t upon tau. Now we further evaluate it. So we can shift this 0.99 to RHS and e to the power minus t upon tau to LHS. So what do we get? So it will become 1 minus 0.99 equals e to the power minus t upon tau. That is 1 upon 100 equal to e to the power minus t upon tau. Tau is 200 microseconds. 200 into here in numerator we can write 10 power 6, or we can write it in reverse way. 100 equal to e to the power positive, same value. So 100 equal to 200 divided by 10 power 6 t. So if we further simplify it, here we can write it slightly differently. So what we have done up to now, we are shifting this to just 1 minus 0.99 equal to e to the power. This was minus t upon tau, and this is equal to 0.01 equals e to the power minus t upon tau. 1 upon 100 equal to e to the power minus t upon tau, or 100 equal to e to the power t upon tau. Now, So we can take log of both sides. So log base e 100 equal to T upon tau. So T will be equal to tau times log base e 100. Now we can put the values. So tau is equal to, we have got as 200 into 10 to the power minus 6 into log 100. It is 4.6. So from here, this value will come out to be 0.92 into 10 to the power minus 3 or 0.92 milliseconds. Now, let's go to question number 10. The plates of 50 microfarad capacitor charged to 400 microcoulomb are connected through a resistance of 1 kilo ohm. Find the charge remaining on the capacitor 1 second after the connection is made. So here we find time constant CR. We put the values. So 50 into 10 to the power minus 6 into resistance is 1000. So this will be equal to 50 into 10 to the power minus 3 or 50 milliseconds. Now, if we find the ratio, the time is given t equal to 1 second. So if we find the ratio of both t upon tau, that is t upon CR. So 1 divided by 50 millisecond, that is 1000 divided by 50. So it will be 20. Now, charge remaining on the capacitor after 1 second of connection is made. So Q is given by Q0 e to the power minus t upon tau. So in our question, Q0 is CV. So capacitance is this much and the voltage. So here total charge in our question is already given 400 microcoulomb. So that is 400 into 10 to the power minus 6 into the e to the power, the value of t upon tau we have found as 20. So minus 20. Now, this from table or from calculator, we can get e power minus 20 as 2.06. Or in question or in the exam, this value will be given. So it will become 400 into 10 to the power minus 6 into 2.06. So this will become 824 into 10 to the power minus 6 or 8.24 into 10 to the power minus 4 coulomb, which is our answer. Thank you for watching.